Hello, everybody. I am from the University of Córdoba. I am now my current position is Ramón y Cajal. I have international experience, and I try to work in no focus in the synthesis of biopolymer or in the production initial step of the production. I have more interest in biopolymer in recovery process in the end of the process and recovery all of this material. Uh, this is my group, Bioside, is working in materials and bioenergy from engineering school from University of Córdoba. So I told before that I'm not focused in the beginning of the synthesis of my biomaterial. We have the positive of bioreactor and synthesis of biopolymer. But for me, the most interesting is we are creating a new scenario of polymer. For example, in 3D printing. In the future, maybe we have a 3D printing farms, and also working. We did a experiment during my Marie Curie in try to taking all of waste from this from the maker space that is similar to the 3D printing farmer, and try to do a protocol that recovery all elements. And before of this process, we need to make a sorting and then to try to combine with other material with, for example, PHA, no? And also the pH that are using also to try to recovering. Also, we work in the concept of biorefinery and all of waste that generate organic waste. Also, will be interesting to try to find new biomaterial with fungins that create a micro structure, and then you can create material that can be used like panel in building. And so the idea is to be disruptive in combination of waste and application of biopolymers, no? For this, for example, where we want to recovery, we are focused first in plastic sorting. In this project that with working with farmer or maker space from the university, we will try to make a classification. We take a 215 sample and then to the different spectrum in infrared, also working in near infrared, hyperspectral camera, and then to try to apply the chemometric analysis in order to shorting, for example, biopolymer, standard biopolymer. We can speak of PLA and maybe another kind of polymer, TPU, the conventional polymer, and also to try to detecting if these polymers are blended or are mixed, no, in order to try to make the correct recycling of the process. With this data, we did a typologic analysis of, we can know exactly in this maker space which quantity of TPU, PLA, this PLA is filament or is element has been printed, and with element can be rejected. With this element, we did a lot of, we did a filament, we did 3D printed, but all of this experience going to the final process that we want to land to make the classification in very complex matrix that we have different polymer, and then to go to the industry in order to recover all of this plastic in direct correction, but not only in the end of the process. We want also in the beginning of the process. We now try to analyze rheological property of the biopolymers like PHA or PLA. Also, here have blender and X-rays, sacs and wax of all of this biopolymer mechanical property, and associate the spectrum with all of this property using a predictive model in order when you are producing this polymer, and sometimes it's difficult to have a standard polymer, okay, we can try to identify this property in something quick like a predictive model in second and try to improve the process of the standardization of this polymer. This is one step that we are working also when we are recycling all of this process. So, but not only working the sorting process, not only working the prediction model is the first step for making decision for the rest of the process. Also working with structure, geometry. We're working with microstructure from fungi filaments, working with macrostructure in 3D printing, and try to make a combination of this structure in order to improve or reduction of the zone, understand the heat transfer, or maybe also like filter of particular matter that can be applied in building, in automotive sector, etc. No? This is also in the microstructure working in electrospinning. This is electrospinning of filament of PLA and PHA in order to try to find a structure that can be can reduce all of element, for example, particular matter, and can be used like filter or maybe to reduce the sound, no? And finally, speak before that we are very focused in recovery of the material. But if you recycle it, PLA or PHA, and we are working in this, you have some moment that you cannot use. Or maybe, for example, you make a composite with lignocellulose with PHA or PLA, you cannot use more. But this material can be recycled and discovered in thermal degradation that you have a combination PLA with biomass. Here in Andalusia, in Cordoba, my city is oliva pomace. We can find synergy that improve the pyrolysis process and maybe improve the energy recovery or production, for example, SAF, aviation fuel, or maybe some precursor of polymer, or maybe biochar that now I have a lot of application in agriculture. And also observe that biopolymer like PSDs can be go to process like anaerobic digestion. And for this, for us, the important is with this finish to use the prediction model to improve the recycling process and the production of biopolymer, to use the micro and macro structure in order to improve the process in filtration, particular matter, reduction of the noisy, improve the heat transfer in order to find application in automotive or another sector. And finally, if in the end of the cycle of the life of the polymer is biopolymer, but there is a new scenario, okay, we will try to try and transform into energy and to find the best way to transform energy. So thank you for the opportunity of this event, and I finish.